Good evening, everyone. We are Team 7. We are here to present our project. So our project is about a grocery store management system. Our system aims to address some challenges such as inventory mismanagement, customer preferences, and streamlined communication between users and inventory managers. Here's a quick look of today's agenda for our project. So we'll start with motivation and background. We'll go through the overview of our application, the methods and approach we followed. We have a live demonstration, and we will conclude with the future work for this project. So I'm Steffi Dorothy. I am a master's student in data science. My undergraduate major was in IT. My interests are machine learning, data engineering, and data analytics. So, in today's grocery industry, inventory mismanagement is a critical issue. It leads to 8 to 10% revenue loss, which could easily be avoided with the right system in place. Our goal is to mitigate this loss by developing a role-based platform that serves different roles such as customers, inventory managers, and employees. Each user role has tailored functionalities to improve the overall workflow. Customer engagement plays a significant role in the system. We collect user preferences and user reviews to provide personalized recommendations. This engagement not only enhances the shopping experience, but also helps us understand customer needs better, allowing for more accurate inventory forecasting and product recommendations. Ultimately, the aim of our platform is to boost store efficiency by integrating user behavior and inventory data, optimizing how products are managed and recommended based on real-time user feedback. Now let's move on to the background work that we did. So firstly, we started by gathering user preferences, basically collecting data on what customers are looking for, their product choices, dietary restrictions, and even their brand preferences. This step is crucial for personalizing recommendations and ensuring that the right products are available at the right time. We also took into account the role requirements for each user. For example, inventory managers need a system to monitor stock levels, receive alerts for low stock, and manage product orders. Employees, on the other hand, need an interface to assist customers and track product movement within the store. This way, each user can perform their role efficiently within the platform. We then tested existing popular browser platforms to identify features that we could incorporate into our system. We focused on platforms that had intuitive UIs that were easy to use for both customers and staff. This helped us shape the user interface and ensure the platform would be simple yet powerful. Now, moving on to the overview of our project. We began by identifying key user queries like product searches or dietary preferences, which shaped our data structure and functionality. Next, we designed an entity relationship diagram to map how entities like users, products, inventory, and transactions interact. This formed the foundation for our backend. The middle layer connects this database with the user interface, ensuring data is delivered quickly and accurately. We also created UML class diagrams to visualize system components and their relationships, helping us stay organized and feature complete. To improve speed, we added caching for frequently accessed data, reducing wait times for product searches. And lastly, we prioritized a simple, intuitive interface, making sure both customers and staff can navigate the system easily and efficiently. And now I would like to hand it over to James to take it further from here.
Thank you, Steffi, for the handoff. My name is James. I am currently pursuing my master's in data science, and I work full-time at Oracle in data analytics. I have a growing interest in everything data science, specifically machine learning, AI, LLMs, and I do have a soft spot for data engineering. For my part of the presentation, I'm going to break down our approach to this project, which I split into 3 phases. The opening phase, phase 1, was all about putting together the blueprint. We started by mapping out the different users that would be accessing our application and the different functionalities needed for each of these roles. We landed on a total of 4 roles: customer, employee, store manager, and vendor. Establishing well-defined user roles and functionalities allowed for a smooth transition to design the Entity Relationship Diagram, or ERD for short. Then, as we were developing the ERD, we were also brainstorming common user questions and then matching hypothetical SQL queries to help us understand which joins and views within the database we had to prioritize accessibility for. We invested heavily into the blueprints of the project because this was going to be our set of instructions for the entire application build. The second phase was going to be more of a transition phase between our project blueprints and the actual application coding component. Following a similar strategy in phase 1, our objective was to avoid jumping head in to the coding without a clear understanding of all of the necessary components. As our application was going to be fully dependent on our SQL tables, our first objective in phase 2 was to convert the ERD into a relational model. This step took the most amount of time because there was an endless list of requirements that needed different constraints, triggers, and cascades. Next, we had to pick out a Python package to start our web development. As our exposure to web framework was limited as a team, we dedicated time in phase 2 to researching the different options available to us. Based on online threads and documentation, Flask promised an intuitive and fast out-of-box setup, making it our #1 pick. So Flask solved our web framework part of the project, and now we needed a way to connect to the database. So this is where our research led us to Oracle DB, a Python package that lets you set up a database connection and execute statements against the database. Now with our packages figured out, we had to pick a place to merge together all of the code. GitHub was the immediate choice because of its unmatched ability for enabling collaboration on code and coordinating version control. The final part, phase 2, took us back to our ERD and SQL code as we set out to normalize the database. As a team, we applied decomposition and compared functional dependencies to achieve 3NF and achieve a higher efficiency within the database. Lastly, the final phase, phase 3, was when we put on our fingerless gloves and started to code. This is when we used all the Python packages that were first downloaded in phase 2 and put them to work. The main challenge with this phase was learning how to use each of the tools. To overcome this barrier, we were constantly sharing documentation, guides, YouTube videos, and more within our group chat to support the application development. On top of sharing these resources, our first 2 lines of code that were committed to the GitHub repository were Python functions that handled the database connection, pulling select statements and storing that output into a data frame, as well as running insert and update statements for different tables. Starting with these functions helped us avoid each writing the same lines of code over and over and gave us all a good place to start. So phase 3 was the last part of our development and would have been the end if everything happened as planned. However, as we don't live in an alternate reality, we needed one final part: repetition. The repetition phase was cycling through each of the 3 phases over and over. The process would normally be that a bug was caught out within a specific functionality, like, for example, if there was a table missing that caused the web page to crash. This would then require heading back to the ERD to add in the new table before writing it out and creating the table in the SQL code, and then finally implementing the Python code to wrap everything together. This was easily the most important part of the 3 phases because we each worked on our code independently before pushing it to GitHub. So we had to test out every detail to make sure that all of our parts fit together. That covers all of our phases, and I will now pass the spotlight over to Ziang to start our app demonstration.
Okay. Thank you, Jim. Hello, everyone. My name is Zhiyang. I'm in data science program. My undergraduate major is mathematics. My research interests are large language models, generative AI, and reinforcement learning. I have a 2-year working experience in database management system kernel. Next, we're going to show a demonstration about the events happened in grocery store during a day. There are two characters in our demo. Henry, an inventory manager, used our system to monitor the commodities. Sophia, a girl likes shopping. She is a customer. First, let me launch our system. In the morning, Henry came to the grocery store and started to work. First, he logged in his account. Okay, the home page is showing his personal information. His name is Henry, and his SSN, birthday. His position is the inventory manager, and he is the manager in 001, 0, and 003 in inventories. Then he punched in. As successful. He was a little concerned about the system's stability, so he checked the punch record again. Okay, the punching record successfully stored in the database. In this system, he can also check the inventory items. We have a commodity ID, commodity name, price, category, discount, and expiration date. These are basic information for commodity. We also have a quantity and a threshold. Quantity store the current commodity amount, and the inventory manager will receive an alert if the quantity runs lower than the threshold. The manager can also check the concrete comments left by our customers after purchase. Then he checked the alerts to make sure every commodity has the enough amount. Here, he didn't receive any alert, so he doesn't need to do anything now.
Hello everyone, I'm Muskan. I'm an MS Data Science graduate student. My interests include machine learning and AI, and I have a work experience as a former technical analyst at TCS. So I'll be continuing the demonstration of a day in grocery store from Sophia's point of view, who's the customer. Here we have this login page for the customer side for our grocery store, the daily pick. But since she's a new customer, she needs to create an account first. So here I am filling out all her details. In case she forgets, in case she forgets to fill out anything else, it will throw her an error that she needs to fill out this field. Once her account is created, she can go back to the sign-in page and use her username and enter her password. But in case she forgets her credentials, it will show that these are invalid credentials and she needs to log in using the correct ones. So here is our homepage. She can browse the current deals that are available on green apples, broccoli, avocado. But here we have the user profile for Sophia. As you can see, her details are saved correctly. And she can also add in her diet preferences for the recommendation system. Suppose she's a vegetarian and prefers a particular brand, she can also add her a monthly budget, which gets saved in our database in the backend. And then she can go to the shop button and browse all the products. In case she needs to search for a particular product, she can type in the search bar, and it's insensitive as well. So in case she needs to go back, She can add any amount of quantity. Suppose she's adding 3 bananas. Add to cart. She can go back, add broccoli. Once she's done shopping, she can hit on the proceed to checkout button and it will show her the total and ask her for her shipping and payment details. So in case again she forgets to fill out the details, it will throw her an error. Once she's filled out all her details, she can click on confirm purchase and her purchase has been recorded and she'll get a thank you message and she can go back to home and browse for more products or see the recommendations, which Steffi will tell you. Thank you.
So just like the add to cart button here, we also have a write review option where Sophia can leave reviews for the products. Once she hits the write review button, it takes her to the review page. She can use the drop down to choose the ratings. She can give a comment here for the product and hit the submit review button. So the reviews are stored in the database, and on the customer side, she gets to see if the review submitted successfully or not. And also the inventory manager gets to see the average rating received for each product on the employee side. So this is how the user review system works. We also have a recommendations option. So here the user can enter the category and the user can enter the brand and dietary restrictions, if any, and hit the get recommendations button. It provides the recommendation here. So let's say the user is vegan. It gives the options. What are the vegan products in the inventory? So this is how the recommendation system works. And if Sophie wants to return a product, let's say she wants to raise a ticket, so she can hit the contact button and it takes her to the contact us page where she can give her name and her email and then give a message saying she wants to return a product and click the send message button. Now the message is again stored in the database and now she can smoothly go back to home and continue shopping. So this is how the daily pick grocery system works. Thank you.
Imagine many customers like Sophia keep purchasing in store. In the afternoon, Henry checked the alert again. He found that some commodities were running lower than the threshold. He also checked the reviews left by customers. Then he contacted the vendors for restocking, also sending the reviews as feedback to vendors. After doing this, he punched out and finished all his job today. This is a day in grocery store. Next, Jim is going to talk about the conclusion and the future work.
Excellent job with the app demonstration, Ziyang, Steffi, and Muskan. As just demonstrated, our application successfully executes each of the features outlined in our task table. Muskan showcased the recommendation engine, which lets users insert their preferences and see what products would be recommended based on available inventory. Next, Steffi demoed the customer review, which when searching through the inventory, the customer can give a rating as well as add in a comment. This rating then shows up on the back end where the inventory manager can see the average rating for each product. And then the store manager can decide if the product should be replaced with one that has more potential. Next up, Ziyang showed the employee side of the website where the inventory manager can view a number of key operational details, including an alert if the quantity of a product falls below a certain threshold. Then the second and the final function in the task table that was showcased by Ziyang on the employee part of the website was how an employee can punch in and punch out, as well as view their time card. So overall, we were able to follow our timeline according to the Gantt chart that we created at the beginning of the project, and we executed each function captured in the task table. This project exposed us to the full application lifecycle and gave us an opportunity to apply what we learned in class to a real-world example. We now each have a stronger foundation for designing efficient database systems and prioritizing details like normalization because of the way each of these aspects impacted our own application. Along with forging our application development skills, the caliber of this project required a serious amount of team collaboration. We had to be in constant communication and discuss every detail from coding structure to key user functionalities. And without a strong team backing, our project would not have seen the same success. Finally, this project pushed us to think intensely about user-centric design. As much of our coursework does not ever reach an outside audience, this introduced a new way of thinking that is much more applicable to the real world. So to conclude, this project was challenging in all the right ways, and we all feel much more confident in our abilities to design a database to support solving a real world problem. Moving forward, future work we would like to prioritize is expanding on the recommendation model. The next version that we would like to implement is one that recommends a specific recipe based on available ingredients, as well as takes into account a user's budget to pick out which ingredients to suggest. The second functionality we would like to expand on is the review part of the website. Now, currently, the reviews are only visible to the backend, which we would like to change and give all app users the ability to not just write, but also to read reviews too. Then the final two details that we would like to work on is to clean up both the interface and the SQL code. As our HTML skills are not that sharp, there is definite room for improvement, and for the SQL cleanup, we have tables that we created in the beginning, but ultimately were not needed in the application. So with that, that concludes our presentation. So thank you all for listening. I'll now open up the floor for questions.